server that allows you to turn any HTML site into GraphQL API. So if you look at the example in the site, it has a Hacker News site URL where it's trying to get the link and its title, href, class, and class list. As you can see here, it's trying to get the attributes ID from the attribute with the name ID from tr.anthing, tr.athing. Alright, so going to the code base, so what CoolQL uses under the hood. So first, let me show you the project structure. So this is what CoolQL has. I hope this is visible. So it has a README, an index file, a package log, package.json, and pages and schema. So it's pretty straightforward, pretty small, simple app. Uh, so let me deep dive into its internals. First, let me start with the package.json to show its dependencies. So the major focus would be Next.js is what it's using. Cherry.io, Express, GraphQL, Next, as I mentioned, Nightmare, and Now. So this is pretty much the dependencies of CoolQLCool. Now let's look at its internals. So just to build it, so I have done node build, node run build, npm run build, and then I would have to do so npm run build gives me .next folder. So I could do .next show me everything which it has, right? So this is what it has. Okay. I'm not going to go into the output. I'll leave it to the as an exercise to the viewer. So npm start is all I have to do to run this. Okay. So I haven't run npm install since I've pulled the latest changes. So of course, it was the latest change which was merged recently into this repository. This was done by Alexander T. He has added course support, so he has required course, and that's pretty much how he has done it. I think the question uses Jan.log, more than package. Using package of this one, I like a pretty model fix, and this should be it. And now I should be able to run build and start. So npm run build actually runs next build. So as you can see in the package JSON. So you have the next build command which it runs, and start runs the production version of the app. So I could run the web dev version. And it should be fine. Look, and it does not really have much of a difference. So let's see. So the graphical interface for that same thing. I have a sample query. I'll first run that. So this is from money control site. It pulls in Asian Paints, previous year's balance sheet and all that financial data. Look at it. Yeah, so this is what it is, and it does look good. I really like the output. So I had to add a wait into it so that it actually waits for the JavaScript to load. So I've added a 1 second wait and number of rows and all that. Okay. Anyways, before I go into this query, let's first go into the internals of CoolQL itself. So what CoolQL itself contains? So, yeah. So what CoolQL itself contains is a set of scraper and parsers, right? So we have, remember I talked about Cheerio and Nightmare. So Nightmare is a tool used to load the HTML content, is to fetch the HTML content. So okay, before that, so index.js. So the CoolQL site itself is served using Express.js. It uses Next.js apps.prepare and then uses Express to serve the app. The server listens on port 3000, whatever port is passed into it. Um, it either picks up from the environment variable or it picks up 3000. And then we have the if the node environment is not production, then it's set as dev. So next dev is set, and then after prepare is called. So this is how it gets run. So if you have not used next, it looks something like this. You have the create server, HTTP instead of, you could use HTTP directly instead of using Express. Parse is just to parse the URL. Next, what we are requiring, this thing is the same. Get request handler, so this also is the same. And then after that, what we have is so, yeah. So we have the handle use only one place actually. The rest of the places it's served using Express. So we have to parse. It loads up. So this example in the Next.js custom server and routing example, it resolves /a to dot/pages b. So Next.js has this pages concept. So let me show you the directories again. So we have the pages directory. So this contains underscore document.js, index.css, and index.js, right? So these three directories, index.js is what's called. Underscore document is something which is like a layout for Next.js to use. Index is where the meat is. Index.js inside pages is where the meat is where the CoolQL site is loaded. We still haven't come to the part of graphical and the GraphQL API itself. So this is just to serve the static landing page itself. Fair enough. I hope everyone can wait for this. Okay, anyways, I hope everyone likes this. Everyone got this till now. So moving on, we have the server.use. Let's see if the recording is. Yeah, okay. So I'm still streaming. Okay. So the other thing which is used is GraphQL and GraphQL HTTP. So GraphQL is a reference implementation of GraphQL itself. This is the JavaScript reference implementation for GraphQL. It's by Facebook themselves, I guess. Um, yeah, it's by Facebook themselves. So pretty much a standard GraphQL JS implementation, which you can find. So what we have is a what we have is build schema, GraphQL being called. to build a schema and to serve the response. So this schema, so it takes in a schema which is defined in schema index.js. We'll go to that, but before that, so GraphQL. Yeah. So this is where GraphQL is used. Sorry, I think yeah, this is where it's used. Sorry. So GraphQL query is what comes from the API from /GraphQL. So graphical serves the UI again. It serves CoolQL graphical UI. The one which you see over here is actually a frame, iframe. So this is actually here. This is pretty much it. Right. For some reason, it's not working on CoolQL side, but it does work on my local local run of the app. I didn't exactly know why, but it gives a 502. I'll probably let it run and show you the output. That's one. What else? What else are you looking for? Oh yeah. So how does graphical work, right? So graphical has this schema which is loaded, and that's pretty much it. Like that's all it needs, the schema, and it just works. Yeah, that's all it needs. But it actually sends the query onto GraphQL. So let me show you in network on this page. Click tab. Everything is getting recording. Yeah. Let me run it again, and it does a post on. Oh, it does it. Yeah. So it does a post on graphical itself. CoolQLCool also provides a /GraphQL API endpoint, which can be used to which can directly be used to curl on. So you have this, and you can directly curl or send a query, a GraphQL query, onto the /GraphQL endpoint. So they have the Ruby, JavaScript, and curl examples. It's pretty much the same example you see over here, like on the landing page. So yeah, so it just gets a query. If there is a query, it basically passes it on to the GraphQL schema query, and then returns the response back onto the um, returns the response back basically. Yeah, that's pretty much it. Yeah, and get star is for handling the pages. So remember I talked about pages here on the bottom right left side. That's pretty much it. And what else? Okay, so let's go deep into the schema part of it, right? So I'm requiring GraphQL. Again, the Facebook's reference implementation, not Express's GraphQL API. So Express GraphQL, it just takes in a schema and it just works. Module provides a simple way to create an Express server that runs a GraphQL API. Awesome. Let me get some water. So you could look at the tutorial for examples. So this was the one which we are seeing in over here, graphical, served using Express GraphQL. The GraphQL endpoint is served using GraphQL reference implementation by Facebook. So let me go into deeper into the reference implementation. So the reference implementation takes in a schema. What is a schema, right? A GraphQL schema is something which takes in a query. It takes in so for queries, it takes in a GraphQL object type. So we are saying that this query, this GraphQL schema only has queries available, And using these queries, you can get you can fetch using site parse. So if there's a field site, it would parse that. So let me pull up that reference query which I had. Um, yeah, so I got the GraphQL highlighting. I just installed that plugin today. So yeah, I installed the one by Kumar Harsh. Seems like a pretty neat implementation. It just works for me right now. Alright, so the fields, it looks for site, and if it sees site, it runs the parse function on it. So parse is an implementation again within CoolQL. It's written by Gavin himself. So the site takes in the fields like select all. Okay. So the site takes in the arguments like URL, HTML, wait for selector, and wait for function. These are all the things which it takes in. The resolve function. So parse is basically a object, JavaScript object, which has a async function in the resolver and arguments which get consumed by the site feed. Right, this should be straightforward. Like I don't really need this to just pretty much run without writing control. But so this should still work. Just that it would be site now. Yeah. Yeah. So I could rename a variable using excuse me. Rename a variable on GraphQL just by pointing it, just by giving it a key. The value automatically becomes the value itself. It would be money control instead of so. Right. Got it? Awesome. I hope this makes sense. Um, okay. Moving on. Nothing. What have I been doing? I'm sorry. Let me just recollect where I was. My cold is killing me. Um, right. So I modified that thing. So site pretty much takes in all these arguments, and the resolver runs to fetch these arguments. So what is the site itself, right? So we have the type site which we are defining. So we are saying, hey, this is a GraphQL object type whose name is site, and its fields are. It takes in fields such as count, select all, uh, yeah, where's text defined? It should have a text somewhere. It has select and select all, um, and resolver just counts stuff in the count function. So count has a resolve element dot resolve. So it uses element dot resolve, which is yeah. So it has an element dot resolve. So each of select and select all have an element dot resolve, which they use to resolve stuff. So apart from what we have, count, select all, and select, we also have fields like okay, nested fields of select, select all, which in turn have the same resolver actually. Um, yeah. Okay, so I'm not going to go deep into that, but you have the count again. Then you have class list, class, HTML, text, href, source, data, attribute, and all that. So all these resolvers are custom written like for each of these attributes, the resolver looks at how to fetch that particular attribute. I hope this makes sense. So this is a GraphQL object type which is being defined. Element is another nested deeper, it goes deeper. Um, so this is pretty much it. So this is how it's working. At least this is how it's structured. So now let's go deeper into how it works. Let's look at each of the resolve functions. So at the root level, what we have is the site parse. So this site parse has a resolve method. This resolver is an async function which takes in the root and the arguments. So root is declared, but its value is never used because there's like really nothing to read. So I might have just put underscore in it. And then we have the args. Args.html. If it's HTML, it just does a cheerio.load and it returns this resolver. Whereas if there is no URL, so if there is no HTML and there is no URL, then there's at least something to be expected. So it just fails at this point. So if I just give site, it will just fail. Right? Expected URL argument to be present. It throws in this error. So money control is null. Message is expected URL argument throws in locations. So it throws a new error, and how GraphQL works internally is that it parses errors. It catches errors and nest them into an array. And yeah, that's it. And now the third so we have another third if condition, which looks at wait for selector, wait, or a wait for function. So if these three functions, if either of these three are present, then there's something different which happens. Before I get into that, I'll first talk about the default behavior. The default behavior is just it uses a fetch, which is like Ajax normal fetch request, fetch API request, which gets the plain HTML without running any of the JavaScript, and gets the text, and then does a cheerio load and passes it on and returns it basically. So that's what it does. In the case of when there is when there is no wait for selector and all that. But when we have any of the wait for selector, wait or function, wait for function, then what it does is it returns a nightmare. It starts up a nightmare session. So Nightmare is a simple high-level browser automation tool. It's similar to Casper.js, or Phantom.js, but it's roughly twice as fast and more modern. It's actually pretty good. I just tried Casper.js today instead of using Nightmare, and I could see the performance being pretty slow with Casper.js, but with Nightmare it was pretty fast. So it goes to the URL, waits, executes the wait, and then evaluates the document's inner HTML. Once this is done, then it basically passes the body and passes it on to cheerio.load. Right? That seems straightforward, simple, easy to understand. I remember a commit a few days ago by Guru. So this is inside index.js. So yeah, so you could see GraphQL actually response.json is both data and errors which gets passed. Right? Okay. Cool. CoolQLCool. So back to Nightmare, right? So it does that. Nightmare just waits for the HTML to load properly and the JavaScript to run based on this wait condition, and then it passes on the loaded HTML content onto Cheerio and goes on its way. So once the parse function completes, the second level of functions resolvers start executing. The second level consists of the site resolver. So site resolver has the select all, and count, which has the element dot resolver. So you can embed select and select all, like the way it's done over here. So select all, the first level it's calling this resolver, and this second level is being called from this resolver. I hope this makes sense. So you have GraphQL, Cheerio, and underscore being loaded. So since underscore is being loaded, I should change it to could perhaps mark it as underscore 2 because it's not being used at all. Awesome. Cheerio, GraphQL, Cheerio, and underscore. So we have the GraphQL client. This is our element type GraphQL string. Resolve. The selector is a HTML selector. Return true so that all HTML words without it would not parse correctly or not. Okay. GraphQL type, GraphQL object type. Fields are select. So I think at this point, the entire library becomes clear. I could stop streaming at this point. This is a 30-minute video. This is what I was intending to do. And I think I've explained pretty much how it works internally. Um, the rest of it, it uses Cheerio to parse individual elements, individual GraphQL queries. So HTML resolves to dollar of root of .html. Similarly with the other types. So select resolve actually passes in all that, right? Got it? I hope that's it then. Thank you. Thank you everyone.